Hi, so this is a little demo of my implementation of homework 2. I'm going to start Python with the root privileges, and I'm going to import the trace module, which contains all the classes and functions that I've written for this homework 2. You see the first message, the warning that comes from Scapy, which we're going to use to do TCP-based traceroute, and then the second message that tells us that there is a document collection referred as trace.call that we can use. If I call the count command, I see that I currently have 0 documents in this collection that's using MongoDB in the backend, and we'll get back to that. So the first thing we want to do is build a list of targets. So result equals trace, and we're going to call the brute force reverse DNS on an entire subnet. So not really smart, but this should work. There we go, and now we'll look at the function later. It returns a list of tuples of IP addresses and host names. So now what I want to do is that for some of these, not all of those, because this would take too long, I want to actually create an instance of a target. So in the trace module, there is this target class. When we pass it the tuple, it's going to create an instance of that class, and then we point to the collection so that it adds this target to the collection. And we call the make target command. What the make target command is going to do is that it's going to run an nmap scan, and you see the command right there. It's pretty basic, scene scan on that IP address, and oops, here we have the nmap results, and then it runs the Scapy traceroute, and here we see the result. And now we are on to the nmap of the third one, again, the traceroute, the nmap of the next target, the next IP address, 39.154. Once it's done with this, only SSH and HTTPS open, it runs the traceroute, and we are done. Now, if we look at how many entries we have in our collection, we see that we have 3 entries. And if we do get all targets to look at actually what are the documents stored in there, we see that we have some nice little dictionaries stored in our document database. We have some keys such as timestamp, which is the time at which the target was created, the object ID that was automatically inserted by MongoDB, the host name, the IP address, the ports that nmap return, and the traceroute, which contains all the hops that it takes to go from my machine here at home to the target. So now that we have those documents in there, what we want to do is simply call the command to actually create the graph of all those hubs. So we're going to select some targets from the collection. So trace.collection, we're going to find them by specifying a specific IP address like this, and we do this by using a regular expression just like this, and passing the regular expression being some IP addresses. We could have many different targets in there in different subnets, and only want to select a subset of those. Here this is actually going to select all of them, but that gives you an idea of what those are. And now what we do is that we call trace, we call the traceroute plot from the database, and we pass the targets returned from the selected from the collection. It plots, it prints out the actual hops defined in list. Here we're done, and if I go here and I open the PNG file, you see that I get my nice graph. Most likely my source is here, and I see the many different hops over the DSL network, AT&T, and then I reach the Clemson network and my 3 targets right here. If we have a look at the code quickly, we'll see the brute force reverse DNS function, which just uses the socket get host by address to get the host name and the IP. The class, the target class, basically just gets the collection and then sets the IP address, the host name of that target dictionary. The make target function basically calls the nmap scan and the trace route, and every time you call these, basically you set the return value as the value for that particular key. So for example, if I look at the nmap scan function, the ports returned by the nmap scan are set as the value for the port's key. Going down to the nmap scan, this is a simple sub-process call to this function, and we could get much more fancier with the nmap scan that we choose to do. The SCAPI traceroute just calls the traceroute from SCAPI to do a TCP-based traceroute and not an ICMP-based one. However, I did include a local traceroute in there that's going to be ICMP based and most likely blocked by the firewall. To get the plot from the database, basically I get the targets from the collection, and you see that I define the hops as the list returned by the value of T traceroute. I add the node, which is the IP address, and then the edges from the hop to the IP. Finally, I do the plot, the PNG, and I save everything in that .dot file, which I can then open with Gephi. And that's it.